Okay, so today we'll be doing some go-react dimensional analysis IV infusion questions. So the first one, we have the doctor ordered normal saline to infuse over 125 mLs per hour for 12 hours. And then we have a 15 drops per milliliter calibration set available. So we want to calculate drops per minute. So that's what we're going to start with, drops per minute. Available, we have 15 drops per ml. So we're going to start with what's available. Then we're going to take what was ordered and have 125 ml over an hour, but our units are drops in minutes, so we want to go ahead and get rid of the hours and convert them to minutes. So we have an hour over 60 minutes, and then we have our mLs canceling out here and our hours canceling out here, so that we're left with drops over minutes. When we do the multiplication, we are left with 1875 drops over 60 minutes, which equals 31.25 drops per minute. And we're going to go ahead and round this to the nearest whole number, which is 31 drops per minute. For number 2, we're going to use some information from the first problem, and we want to find out how much normal saline is infused over a 14-hour time period. So we have infused over 14 hours. We're going to take the conversion here of 125 ml per hour and use that 14 hours here. So we want the hours to cancel out to find out how many mLs are infused, and when we do our multiplication, we are left with 1750 mLs over 14 hours. Not per hour, over 14 hours. So then for number 3, we have 150 milligrams ordered over 15 minutes, and then it's available in a 50 ml bag. We want to find mLs per hour, so we're starting with mLs per hour. And then we're going to take 150 ml, which is available over 15 minutes, and we want per hour, so we want to cancel out these minutes. So we take 60 minutes over an hour, these minutes cancel out, and we're left with 3000 ml over 15 hours, which is 200 mLs per hour. For number 4, we have ml per hour, and then we have the Vanco infusing over 90 minutes. That's the order of 1 gram over 90 minutes, and it's available in 1 gram per 250 mLs. We want to calculate the flow rate in mLs per hour, so that's what we're starting with. We take what we have available, which is 250 milliliters over 90 minutes, and then we want to convert those minutes to hours. And so we have 60 minutes over an hour, and when we do the math, when we multiply, we get 15,000 mLs over 90 hours. And when we divide these two numbers, we get 166.7 mLs per hour. Okay, for number 5, we have a patient sedated, and the rate is set to 36 micrograms per kilogram per minute, and the patient's weight is 187 pounds. That will be important for later. And then we have available 500 milligrams in a 50 ml glass bottle, and the flow rate is mLs per hour. So we're going to start with mLs per hour here. We're going to start with what we have available, which is 500 milligrams in a 50 ml. So we want to find ml, so we have 50 ml on top and 500 milligrams on the bottom. We want to cancel out these milligrams, so we know that 1 milligram is 1,000 micrograms, because we're going to want to cancel out this unit here, which is 36 micrograms over kilograms per minute. So we know once that we have this conversion, we can cancel out these micrograms here. And then we want to cancel out these kilograms. So we're going to use the patient's weight here and convert these pounds to kilograms. And so 187 pounds over 1 times 1 kilogram over 2.2 pounds. So we're going to go ahead and these pounds cancel out, and this 1 kilogram cancels out here. So now we just left with a minute, which we want hours. So that's where we're going to have this time conversion here of 60 minutes over an hour. The minutes cancel out, and we're left with mLs in an hour. When we multiply the numbers on top, we get 20,196,000, and the numbers on the bottom equal 1,100,000. When we go ahead and divide these two numbers, we get 18.36 mLs per hour, and that matches our units from the beginning. Okay, and finally number 6, we're going to use this number from up here, from number 5, and use it to solve number 6. So we have drops per minute. So we have 60 drops per ml, which we have here. This is what we have available. And then we are going to take our conversion from up here and take 18.36 mLs per hour and then we don't want hours, we want minutes. So we're going to go ahead and take 1 hour over 60 minutes so that our hours cancel out. And then when we multiply top, we get 1101.6, and when we multiply the bottom, we get over 60. And then we get, when we divide these two numbers, we get 18.36, but we want to round to the nearest whole number. So we're going to go ahead and round. This is not greater than 5, so it's going to be 18 drops per minute.